All right, everybody, welcome back to another study guide, this time the Algebra Unit 7 study guide. This unit is where we began to learn about quadratic functions. Up until this point, you had only known about linear functions, that is, equations that would form a straight line on a graph, and now we're learning about quadratic functions. And quadratic functions, we had quite a few notes in your notebook. If you look on my webpage, on the left side, you'll see notebook pages, and if you pull up Algebra, you'll be able to pull up all of the Unit 7 notebook pages that give you all the good info that you need to know about them. Let's look at Learning Target 1. I can confirm algebraic intercepts and the vertex of a quadratic function using a graphing utility. So using a graphing utility is key. There is a way to do this by math. If we look at number 1, for example, we do have an equation that we can use to find the axis of symmetry by math. It's called, we call it the discriminant, and it's x equals negative b over 2a. So b is 6, so that would be negative 6 over 2 times a is 1. That would be negative 6 over 2, which would be negative 3. So the axis of symmetry would be x equals negative 3. In other words, a vertical line through the exact center of our parabola, that is the axis of symmetry, and the equation for that would be x is negative 3. The vertex is the point right here, either the minimum or maximum of the quadratic. And we could do all that. We could do that also by math. We could take our x value, which we now know is negative 3, and we could substitute it back into the original equation. So negative 3 squared plus 6 times negative 3 plus 4, which would give us 9 plus negative 18, which would be negative 9 plus 4, which would be negative 5. So our vertex would be negative 3 comma negative 5. We can do this by math. Okay, or we can use it using a graphing utility. If we're going to use a graphing utility, it's very simple. All we have to do is type the equation into Desmos and look at the graph. So let's take a look. I have the first equation typed here. If you want the vertex, if you click right there at the minimum point, there it is, negative 3, negative 5. And the axis of symmetry would be the vertical line that goes through the vertex. And since the x value is negative 3, it would be x equals negative 3. So we can do this by just by looking at the graph also. So I'm going to erase all of this stuff. By the way, all this information about the discriminant and all that is on page 48 in your notebook, or in my notes if you don't have it. Remember that the axis of symmetry is an actual line, so it's an equation. You can't just put negative 3. We need the equation of the line. All right. Now, if we do number 2 by the graph, let's just go ahead and pull it up, and it is right here. Our vertex is negative 4, 7. So I'm going to go back over here. And the axis of symmetry is just x equals whatever the x value is, negative 4. That is the equation of the line that goes through the vertex. And then finally we have this third one. There's our vertex, negative 2, negative 6. So we're going to come back here. Which means our axis of symmetry is x equals negative 2. The vertical line that goes through, we have this, right? It is the vertical line that goes through the vertex, okay? And since this x value is negative 2, it's x equals negative 2. All right, that part is easy enough. Now, this part is also simple enough, I think. Identify the domain, range, zeros, and intercepts of the function. So remember that domain means all x values. So we have to think about our parabola here. All right, if this graph continued forever to the left and to the right, where would the parabola end? You have to imagine, you see it's going at an angle. So if we went far enough, it would go to infinity. If we made the graph bigger and bigger and bigger and bigger, it would keep going further and further and further to the right. Same thing to the left. All right, so our domain, which is all of our x values, would be all values to the right, all values to the left, and all values in between. So it would be all real numbers. And you may recall that you write real numbers with like an R with a double vertical stem and then the rest of the R. That means all real numbers. Okay, now the range, let me change colors here. The range is the y value. So if I say, okay, where does this go up and down? You can see that this right here is the lowest point, right? Let me actually be able to see the graph here. Okay. All right. The lowest point is right here, but then it goes to every y value above that. So I need to know what this y value is, which means I need to know the vertex. So what I can do is I can use the negative b over 2a. Here's the equation. So b is -1, so negative b would be negative -1. 2a is 1. So it turns out to be 1/2. That's the x value, right? So right here, the x value is 1/2. So the question is, what's the y value? I need to know what this is, so I can plug 1/2 back into the equation. Y equals 1/2 squared minus 1/2 minus 2. So you're going to get 1/4 minus 1/2 minus 2. It's going to turn out to be a fraction. If you would prefer, you can just type it into Desmos and see what it is. Let's see, x squared minus x minus 2. Let's use the last one that we had open. X squared minus x minus 2. So there's our same graph that we have on our paper. And if we want to know what the vertex is, it's 0.5, negative 2.25, negative 2 1/4. So that is the lowest y value. Make this a little bit bigger. Right here, it's negative 2.25 or negative 2 1/4, okay? Or you could call it negative 9/4, however you want to do it. So the range goes from that number up to all real numbers. So y, range is y is greater than or equal to negative 2.25. It's okay with me if you put it as a decimal. Okay, let me erase some of this stuff again. I'm making a lot of marks here. The zeros, when we ask for zeros, what we're asking for is the spots on the graph where y is equal to 0. And when y is 0, we are crossing the x-axis. So it looks to me like it's 2 and negative 1. And you do, remember you make the, that didn't come out very good. You make the curly brace, negative 1 and 2. Okay, those are the zeros. And then the y-intercept is right here. Here's the y-axis. It's where our graph crosses the y-axis, and it looks like negative 2. All right, that's how you do that one. Let's take a look at this guy. I don't think this one's going to require as much math as before. So the domain, again, if we kept this graph going forever and ever and ever and ever, we would eventually hit all numbers to the right and left. So the domain is going to be all real numbers. The range goes from 3 up. So y is greater than or equal to 3, because you see there is a dot on 3. Now, zeros, here's the x-axis. This graph does not cross the x-axis, so there are no zeros. The y-intercept, though, here's the y-intercept, is right here at 5. You could also really, I guess for the intercepts, you really should list it as a point, like that, 0, 5. For number 6, our domain, all real numbers, because we would go all the way forever, left and right. The range, however, goes from 16 down, so y is less than or equal to 16, positive 16. Our zeros are right here. We can list it like this. It's supposed to be curly braces, it's hard. -2 and 6. Or I can list it as points, -2, 0, and 6, 0, okay? The y-intercept is right here, 0, 12. All right, so you just have to be able to look at the graph, and when they ask for zeros and y-intercepts, you just have to know which points they're talking about. The graph will give you the information as long as you know what those words mean. Then we have some word problems. So for the word problems, for this unit, it was pretty easy because you are given the equation, and it's pretty easy to type it into Desmos. You just have to know which part of the graph you're looking at to give your answer, okay? So April shoots an arrow upward at a speed of 80 feet per second from a platform 25 feet high. The pathway of the arrow can be represented by the equation h equals -16t squared plus 80t plus 25, where h is the height and t is the time in seconds. What is the maximum height of the arrow? So the important thing to know is that on the graph, h is your height, t is your time in seconds. Remember that our quadratics are y equals x squared something something x something something, right? So the letter that's by itself in the front is equivalent to y. So that would be this, okay, this axis. So this is, therefore, this is height, and the bottom axis is t, which is time. In seconds. What's the maximum height of the arrow? So I know that she's throwing the arrow or shooting the arrow up in the air, and then it's going to come back down. So we're looking for the maximum height. If we go to Desmos and we graph this, all right, here is the platform 25 feet from the ground. The arrow is shot up. It gets all the way up to 125 feet. And then it starts coming back down again, okay? So the question, let's look back at the question. What is the maximum height of the arrow? So the maximum height of the arrow was 125 feet. Now, you would not give me coordinates. You would not say 0, 125. I did not ask for the coordinates at that point. I asked for the height. Height is a number, not an ordered pair, all right? Now, what ordered pair represents where the arrow hits the ground? So you have to imagine if your arrow is going up and then down, right here is where it hits the ground. So let's take a look on our graph. It would be right there, 5.295, 0. All right. How far does the rocket end up from its starting location? Well, the starting location is here. All right. And we want to know how far. This is in time. I'm not sure that we can answer the question how far. I can tell you how long it would take to get there, but I can't tell you how far because I don't have a distance. This is not a good question. We'll skip that one. Let's take a look at the second one. A rock is dropped from a bridge 320 feet above the river. The pathway that the rock takes can be modeled by the equation h equals -16t squared plus 320, where h is the height of the rock and t is the number of seconds that the rock is in the air. So again, when we're looking at our graph, this is height and this is time. How long will it take the rock to reach the river? So let's take a look at our graph. Here's the equation for this one. So here's up at the very tippy top, there is the 320, and the right side of the parabola where you go down, 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 that's where it's being dropped. There is where it hits the river. The x-axis you could think of as like the river, the surface of the river. That's what I was looking for, the word surface. So how long would it take the rock to reach the river? 4.472 seconds. What ordered pair represents the location where the rock begins to fall after traveling upward? Actually, the rock doesn't begin to fall because it's dropped from a bridge and it's 320 feet in the air. So 0, 320. That's basically the point right there where it starts to fall, okay? Then we look at number 9. A ball is kicked from the ground and travels in a parabola to the net. The ball's trajectory can be modeled by the equation h equals negative 0.25 d squared plus 2d, where d is the distance and h is the height. So we're looking at height, distance. How far away from the kicker is the net? So if the person kicks the ball and it hits the net, that is the net. So the distance would be this distance right here. So let's take a look. All right, we're looking at the red one. All right, the red one starts at 0. That's where the person kicks the ball, goes up in the air, and it hits the net right here at 8, 0. So I'm assuming that's in feet. That would be 8 feet. Yeah, it doesn't say that it's feet, but we're going to assume it. All right, suppose the same kicker kicked the ball from a platform that was 5 feet in the air. The new equation for the ball's trajectory is h equals negative 0.125 d squared plus 0.75 d plus 5. How much further will the ball travel in the second kick? So you're going to see that in the second equation is going to be like this. So you're looking at this spot versus this spot, okay? So if it's how much further, there we go. There's this, actually it travels further the first time, doesn't it? So it would be 8 minus 6.632. And we could do that right here. 8 minus, what was that? 6.632. So 1.368 further. And this will need to be edited because it actually travels further on the first kick, not the second one. All right, now we're going to go to targets 5 and 6. And this is where you had to determine the equation of the curve of best fit. So you may remember when we did way back in Unit 1, when we were doing scatter plots, you had to do the linear regression with the to find the line of best fit. Well, now we're going to do the quadratic regression. So looking at number 10, it says the table shows enrollment at a local college by year. Write an equation for the line of best fit. Ooh, this one says line, so that means we are going to be linear, and then find the approximate enrollment for the year 2010. So we're going to put this table in Desmos, and then we're going to do y1 squiggle mx1 plus b. All right, where it says line, that's a clue that we're doing line. So let's go to the first. Here we go. Here's the table. And now we're going to do y1 squiggle mx1 plus b. And here at the bottom of this box, you see that m, the slope, equals 19.5. B, the y-intercept, is negative 37997.8. Let me try to zoom out so that we can see. There we go. All right, there's the x-axis. So we're going to use the m and the b to write the equation. The equation will look like this. It will look like y equals 19.5 x minus, because the b is negative, 37997.8. And you can see that our red line is directly on top of the black line that it gave us. So let's go back to the page. I don't know why this keeps taking me to that one spot. Write an equation, so that's y equals 19.5x minus 37997.8. All right. Then find the approximate enrollment for the year 2010. So the way you do that is you take 2010 and you put it in right here for x. So 19.5 times 2010 minus 37997.8. So I'm going to let Desmos do that math for me. I'm going to come back over here. I'm going to take this away so it's not an equation anymore. And instead of x, I'm going to put in 2010. Oops, there we go. Times 2010. All right, and I see that the enrollment should be 1197.2, which would be 1197. You can't have 0.2 of a person. Okay. Now, looking at number 11, it says the Sears Tower at 1,451 feet high is one of the tallest structures in the United States. A penny is thrown from the top of the tower. The height, h, of the penny after each second, t, is recorded in the table. Write an equation for the curve of best fit, and then find the approximate height of the penny after 7 seconds. So let's go back to Desmos. I've already put the table in for us. Now, we've been told that this is a parabola. I know it doesn't really look like it. We don't have much data here, but take a look at the dot where 1450 is. That's where the penny started. It went up to the next tallest dot, and then it started dropping, okay? So in order to write the line of the curve of best fit, we need y1 squiggle, a x1 squared plus b x1 plus c. We have to use the standard form, ax squared plus bx plus c, and you have to use y1 and x1. If you look at the top of your table, those are labeled x1 and y1. So we're telling the equation to use those values. So if you take a look at what we have, it is, I'm going to just write the equation right here. Y equals, did it say anything about rounding? Maybe we better not. Negative 16.1429 x squared plus 35.3714 x plus 1450.91. All right, and you see our red parabola over on the graph is right on top of our dots, okay, where we were before. And then I think it said it wanted to know after 7 seconds. Is that right? Let me go back and look. Find the approximate height of the penny after 7 seconds. So what we need to do is we need to substitute 7 in wherever we see x. So we will let Desmos do that for us. So I'm going to come here. I'm going to backspace and put times 7 right there. And I'm going to backspace and put 7 right there. And the question was, what was the question? Was it the height of the penny after 7 seconds? 907 feet. So that's about, yeah, that's 7 seconds. Yeah, about 900, there you go, 907.5, they rounded it, 508. 907, oh, come on. I'm just going to say about 907 feet. Okay, So that's how you do these quadratic equations. We're not solving them, we are just graphing them and then making inferences and drawing conclusions about them, okay? So if you have any questions about how to read the quadratic graph, or what any of these words are, domain, range, zeros, axis of symmetry, vertex, minimum, maximum, how to do the line of best fit or the curve of best fit, please feel free to drop me an email and I'll be happy to give you some extra practice with that. Talk to you later.